Okay, you guys are working on B. Um, Same type of problem, right? Like you have the same exact issues. So you have the ability to find the sine of delta S. You do not you do not have temperature, and you have the ability to find H. So it's going to give us the same issues that we had a minute ago, but it is going to solve the same way. So I would say this is definitely a challenging question because it's not something that you just get a numerical answer. You have to kind of think through it. So this is definitely something that I would be prepared for on the test. So this is a question that especially good to see if you can kind of think through the process. Now it's not an easy question, definitely challenging, but something that you should kind of be prepared for. And so if we kind of understand that process, we can get that good score on the test. So let's go ahead and look at this one. So on delta H, so we know that delta H can be determined by taking our products minus our reactants, and we have a table. So let's go ahead and go through this. So the product is right here. Now this one is balanced at 113. So I would do 3 times the BRF value. And so the BRF value is here. All right. And so notice that on some of these examples, we were doing the 1 times because the coefficients were 1. Well, they're not 1 here, so it's a little bit different. So 3 times that, and then this is going to be your products. So I'm just going to bracket that minus the reactants. So the BR2 is here. So minus 1 times 30.91 plus the BRF3 negative 93.85. Let's see if I can squeeze all this in here. I'm gonna fix it. I'm gonna run out of space. I'm gonna rewrite that real quick. So let's go back and I'm just gonna rewrite this so I can fit this all in. So I'm gonna do 3 times negative 255.6 minus, we had the 1 times 30.91 plus 1 times negative 93.85. There we go. Fit it in there now. Okay, so if you look, all we did, products minus reactants, once again, just going to constantly tell you that this is like super important to remember because you're going to do products minus reactants on so many things. And so this was your product, and then these two were the reactants. And so that's how we set that up. So we're going to do the math here. And this is going to give us a delta H value, and it's going to be in kilojoules per mole. So let's get our handy calculator out. And let's go ahead and run through this. Now, you guys have likely already done this, which means that you're just checking your answers. If you have not done it, remember, watching me do chemistry does not mean you learn any chemistry. So just something to be aware of. So 3 times negative 55, 3 times negative 255.6, hit enter. And then we're going to subtract that from, in parentheses, the 30.91 plus the negative 93.85. Close it up, close the parentheses, hit enter, and go ahead and get yourself an answer. Now, once again, you can't see my calculator here, but if you plug it in like that, you should be fine. As long as you watch your negative sign, and you're going to get negative 703.86. Okay, so that's a good thing if you want your reaction to work, because reactions like negative delta H's, so this is good. So now let's go ahead and look at the formula and see what we can figure out. So the new formula, delta G, the Gibbs free energy, which tells us whether reactions work or not. Basically, if it's a negative answer, they work. If a positive answer, they're going to need a little help. Equals, and let's plug in our delta H. So remember, the formula I'm using is right here. This is not new. Same one that we used last time. So delta G equals delta H minus T delta S. So that's what I'm using. You just can't see it. And so we did negative 703.86. Okay. And then we are going to subtract. So it's going to subtract T, which we don't know, and delta S, which we don't know. All right, so just need to write the formula here so I don't have to keep sliding back up. So delta G equals delta H minus T delta S. Remember, you don't have to memorize this. It's in the data booklet. So we've got our delta H. We need to think about temperature here, and so we need to find the sign of delta S. So let's look at delta S. We have 2 moles of gas on the left, and then on the right, we have 3 moles of gas. There's a coefficient of 3 right there. So they have 3 moles of gas. So if we do that, if we kind of think about how this works, remember, here's the solids. Sorry, it's not solids. Here's the gases. Here's the solids and the liquids in the middle. If we go towards that gas phase, which we're doing, we have more moles of gas. That's a positive delta S. So remember, chemistry, things that happen naturally, they like to have more randomness, more disorder. So if you're going to go towards the gas phase, then that is going to give you this positive delta S. Now, if we went the other way, it would be, of course, negative. All right, so we have verified that this value is a positive number. Do we know the number? No, we don't know the number. We know the sign. Okay, but now let's look at this real quick. What does chemistry like? We talked about this before. Chemical reactions, they like to give off heat, so they are negative delta H's, so this is very good. And they also like randomness, which means a plus randomness, more disorder, and that's what we have here. So actually this equation has 2 things that chemistry likes. But if you just understand math and science, you can look at this and say, okay, I've got negative 703 here minus a positive value. So a minus positive value. So this is going to be negative minus a positive value. So this is negative and a negative, which is just going to make a bigger negative. So no matter what you do here, your answer is always going to be negative. And so hopefully you spotted that. Now, if you didn't, if you do the math, you could just plug in a little simple formula here. If you do the math, it's always going to be negative. So negative 703.86 minus, so let's put in a low number for temperature. and then we'll make this plus 1, or this one, which is going to be, let's put in a big number for temperature. And I usually use the 1s for the S values because, like I said, S's aren't very big. Okay, so once again, if good chemistry student, if the answers are high temperature or low temperature, plug in a high and a low. Figure out what it's going to do. Okay, so negative 700 minus 1 is negative 704. So that's going to be negative 700. Let's use a better pen there. Okay, and then our second one there. So now, once again, it's negative 500, right? So I use 500 because, I mean, it's a big number. You could use 1,000. You could use whatever you consider a big number. It doesn't really matter. But basically, you're going to get negative 1,200 or so. So this is going to be actually 1,203.86. So what you need to focus in on is this. No matter what you do, you get a negative sign, negative delta G. So it's negative delta G no matter what. So what you would say, remember, negative delta G is a good thing. Lost my screen there. I think I'm hitting the keys on the back of the tablet and it's doing something. But anyway, lost my screen for a minute, but we're back. And so at the end of the day, your answer is that this reaction is spontaneous. Spontaneous meaning that it works, or negative delta G at all temperatures, meaning it doesn't matter what temperature you're at, this is going to work. And so this would be something that if you put these chemicals together, they're going to react. So think like vinegar and baking soda. You put them together, they start making bubbles. You don't have to do anything. So this works no matter what the temperature. Temperature makes it work faster, maybe, or more, but it doesn't. Hot or cold doesn't matter in terms of whether it works or not. So, all right. So tough question. I think we kind of went over it, but just it goes back to making sure you plug in your own numbers when you're doing something like this. So, all right, we're going to be moving on the next set. I'll pause the video, but we're going to be moving on here. And so what we're doing here, these are actually easier. On these, you're just going to plug in the numbers and get a number. So we're going to be plugging in values and coming up with a numerical answer. And so these are a lot easier than these because these require the student to really think through the process. And these here